Okay, let's see if I can finish this multiple choice section in one video. Not sure that's going to work. Question 36. So we got a table of value for the output of a function and the output of the derivative. Selected value for x. dy dx is just y prime, right? dy dx is just y prime of x. It's continuous on 1, 5. What is the value of, integral from 2 to 5 or dy dx? Now this question is really not difficult, right? Look, you could, let's do it like that. It's integral from 2 to 5. You could simplify this to dx right here of dy, right? And we know what the antiderivative of dy is, 1 times dy. So it is y between 2 and 5, which is y of 5 minus y of 2. Y of 5 is 50. Y of 2 is 4. So it should be 46, and 46 is A. Okay. Another way, if you want, look, you can say if you replace dy dx with notation, you have like from 2 to 5 of y prime of x dx. Well, the antiderivative of y prime. All right. So another way of seeing this, y prime is just the antiderivative. Y prime is a derivative of y, right? So the antiderivative of y prime is just y. So it's y of x between 2 and 5, and we get back to where we started. Okay. All right, question 37. Question 37, the average value. Okay, well, this is a calculator function. Don't waste time trying to do things by hand. So this is what they want. You need to know the formula for the average value, right? 1 over b minus a, so here it's pi minus 1, integral from 1 to pi of e to the negative x sine x dx. So let's grab the calculator. All right, let's do that. Don't want to last time I kind of wasted time with this thing. Okay, that should be good, I think. So 1 divided by pi minus 1, right, close the parentheses, times, it's math 9, sum between 0 and pi, right here, where's pi? Right there. The function is e to the negative x, so second e negative x, get rid of, okay, times sine x, sine x, close the parenthesis, let me see, I think this is it, right? Dx right here, so I need dx right here. And let's see if we get an answer that we have 0.243. All right, well, let me see what I did. Must have made a mistake in my 1 divided by pi minus 1 times, oh right, you see it. So second enter, my boundaries here is wrong. That's very easy to spot, right? It's from 1 to pi, not from 0, it's from 1 to pi. So enter. 0.128, 0.129, yeah, that's it. So it's A. So which one is it? Right here. So it's A right here. Okay. A. It is 0.129. Question 38. Question 38. So somebody else. All right. The position of an object attached to a spring is given by, so they're giving y of t, where t is in second. Okay, how many times does the acceleration of the object changes from negative to positive in the first 5 seconds? Okay, so shouldn't hesitate too long how to do that. They give us a position function, and the question is about the acceleration, so I have to derive it. Okay, so let me derive it first time. That's a velocity, right? Composition, the derivative of 4t is 4, so it's 4/3, and the derivative of sine is cosine 4t. Derivative of 4t is 4 over 8 is 1/2, and then the derivative of cosine is negative sine, so that will cancel the negative sign in front. It's going to be a plus sine of 4t. Okay, let's do it one more time. So my second derivative is going to be all right, and this is the acceleration. Okay, so the 4 goes down, multiply the 4, it becomes 16/3, and the derivative of cosine is, oh, my negative sign right here, it's negative sine, so negative sine 4t, and then the 4/2, that's 2 plus 2 cosine 4t. All right, this is my acceleration. Let's read the question one more time. How many times does the acceleration of the object changes from negative to positive in the first 5 seconds? So when is this negative? When is this positive? Well, that's pretty simple. It's a calculator question. Let's plug this function into the calculator. So let me take a look at it one more time. It is, oops, not here. It is here. Negative 16/3 sine 4t plus 2 cosine 4t. All right, let's plug it in. Negative 16 divided by 3 sine 4x plus 2 cosine 4x. Now they say in the first 5 seconds, so let's make sure we get the right window. We're going from 0 to 5. Okay, we don't need to go above 5. Y min, Y max, what am I doing? I'm adding some sign. There's a coefficient 16/3. I'm gonna take negative 6 to 6. We'll see. I really don't care about the Y min, Y max here. Let's look at the graph. All right. Ooh, I think there's a change at the beginning, right? Quite a lot, huh? Okay, let's count. So 1, 2, 3, 4, 5, 6, 7. So I believe the answer is E. I hope I'm right. I haven't checked the answer. I'm gonna check it right now, actually. E, this is question 38. Examination 538. Answer is, it's not E, it's A. Did I make a mistake somewhere? Okay, I'm gonna pause. Well, I was really careless. The question says changes from negative to positive. I counted all the changes, okay? So let's look at the graph again. From negative to positive, that's not 1. This is 1, 1, 2, 3. 3 times. So 3 is actually A. I should check the answer. Okay, question 39. You have to read carefully the question. You see what can happen. Question 39. The current price of a compact car is 14,500. The price of a compact car is changing at the rate. So this is rate, so it's a derivative. The rate of the change in price is 120 plus 180 root t dollars per year. What will be the approximate price of a compact car 5 years from now? 5 years from now. So 5 years from now. So now it's 0, right? So I want P of 5, and I know P of 0. P of 0 is 14,500, and I want P of 5. Well, what is P of 5 minus P of 0? It is the integral from 0 to 5 of P prime of t dt, right? Okay, and so P of 5 should be integral from 0 to 5 P prime of t dt plus P of 0. Okay, let's try that. I'm going to take my calculator. Okay, let's go on the home screen. Math 9. And I said sum from 0 to 5. The function is the one they are giving me, 120 plus 180 square root of x, and it's dx. Okay, and let's add 14,500 to it. Here we go, and let's push enter. It's computing. 16441.6. So there's only one possibility, and the answer should be C, right? The answer is C. According to what they're giving me, I would say C. And this is question 39. And 39 is actually C. Good. Let's move on. Question 40. Okay. The amount of radioactive substance decreases according to the equation dy dt equals k times y, where k is a constant and time t is measured in days. Okay, t is measured in days. If half of the present amount of the substance will decrease in 20 days, what is the value of k? So they want the value of k, knowing that half of the present amount will decrease in 20 days. Now, you could use the formula, I don't know if you remember it, it's a formula from Alge 2 PC that tells you the half-life, but I'm gonna do it without remembering this formula, okay? But the half-life is ln of 1/2 over k, I think. But you know what? I'm not even sure. So let's put that, let's not use a formula. So we need to find the function y that describes the amount present at time t, right? So this is a differential equation. Let's separate, well, actually, there's no two variable, right? So we can just integrate both sides. Here we go. Let's do it like that. Let's separate the variable. Let's do it separation of the variable k dt. So now let's integrate both sides. On the left you have ln of the absolute value of y equals, and on the right you have k times t, right? Okay. So I want to solve for, plus a constant, sorry, plus a constant of integration. You cannot forget this one. I want to solve for absolute value of y. We've done this kind of equations before. So you apply exponential function on both sides. So the absolute value of y is equal to ek times t plus c. We've seen that before. This is the same as ekt times ec. And this is a constant, right? But it's a positive constant, right? C is anything, but e to the c is always positive. Okay, positive constant. I'm gonna change its name, and I'm gonna call it, I don't want to call it k because I'm using it. I'm gonna call it p. Okay, so the equation here is the absolute value of y is equal to p times ek t, and let's remove the absolute value. So here you would have normally y equals plus p times ekt. P is right here. This p is positive. Okay, we said it. It's a positive constant. Or p y equals negative p times ekt. Now you see this initial amount sometimes positive, sometimes negative. So basically I can write my solution as y equals p times ekt, and p here is just a real number. That's all. Okay, check out a previous video about solving differential equation, but we went over an example similar to that. Okay, so this question is already a bit long. 20 days is the half-life. So if you look at y of 0, I mean, it shouldn't be, you should have seen this before, right? This kind of equation. It's a decay or growth equation. K times 0, so it's just p. So this is the initial amount. This is the initial amount. So they're talking about the half-life. So in 20 days, the initial amount gets divided by 2, okay? In 20 days, initial amount divided by 2. So let's see what that means. That means that y of 20 is equal to p over 2, right? But what is y of 20? Y of 20 is p times e to the power of k times 20, right? Okay, so now we're back to an algebra problem, solving this for k. Okay, here's the equation, you have to solve it for k. So let's divide by p both sides, and you get 1/2 equals e k 20. Let's take ln on both sides, so you get ln of 1/2, I'm going to need another video actually, ln of 1/2 equals k times 20, and finally, and that's a formula I had right at first, k is ln of 1/2 divided by 20. So let's take the calculator, let's do ln of 0.5 divided by 20, and we find negative 0.0346, negative 0.035, that's D. So this question is actually a bit on the long side. I'm not a fan of it. If you don't know what to do directly, move on, okay? Have time for another? No, I'm gonna stop this video right now and I will finish the last 5 problems on the last video, okay?